Okay, so then we move on to the oxidative phosphorylation. What you have to remember in oxidative phosphorylation, it involves ETC or electron transport chain. What is the first molecule in ETC? What is the first molecule to accept the electron from NADH? FMN, or another name for FMN, flavoprotein. Flavoprotein or FMN is the first electron receptor from NADH. So first NADH, it will go to the first protein complex, the protein complex number 1. So they're going to be a redox reaction. They're going to be an oxidation reduction process occurs. During that process, there's an electron that's going to be donated, accepted, and they're going to be released of hydrogen ion or proton, or H+. So they're going to be accumulation of the hydrogen ion in the matrix. Am I too fast? Can follow, right? Not too fast. Okay. So there's going to be accumulation of the hydrogen ion or proton in the matrix. So when there's high concentration of the hydrogen ion in the matrix, that will make the environment acidic. It will reduce the pH and it will become more acidic. So they're going to be different in terms of the concentration of the hydrogen ion when you compare with the matrix and intermembrane space. Intermembrane space is the space between the inner membrane of the mitochondrion and the outer membrane of the outer mitochondrion, outer layer. Outer, inner, so there's going to be a space that is intermembrane where the hydrogen ion is pumped or transported from the matrix to that space through the protein complexes. These protein complexes are intrinsic protein or integral protein. It uses to transport the hydrogen ion because hydrogen ion is impermeable to the plasma membrane. It cannot simply pass to the plasma membrane. It has to have a medium of transport to be transported to another area. So there's a gradient, there's a concentration gradient that drives this hydrogen ion from one area to another area. So you can call it as the proton motive force. Proton motive force, because that's the gradient, that's the differences in terms of the concentration of the hydrogen ion in the matrix and in the intermembrane space. So when the hydrogen ion is pumped to the intermembrane space, so there's going to be accumulation of the hydrogen ion, but it's being pumped to the intermembrane. So now it's opposite condition. At the intermembrane space, there's going to be accumulation of the hydrogen ion or proton. Then the environment is going to be very acidic when you compare with the matrix, because that's a different concentration of the hydrogen ion and proton at the intermembrane space. So, due to the concentration gradient or the difference of the hydrogen ion, so the hydrogen ion needs to be pumped back again to the matrix, because that's a gradient. That's a proton motive force that urges this hydrogen ion to go back to the matrix. So how are they going to go back to the matrix? Because they don't have these protein complexes. So they have to use a ATP synthase. So they're going to be another pump, which is ATP synthase, to pump the hydrogen ion from the intermembrane space back to the matrix. So during the flow of the hydrogen ion through the ATP synthase, there's going to be a generation of the ATP. So ADP will combine with phosphate and will produce the ATP. That is the oxidative phosphorylation process, which involves the ETC as well as the hydrogen ion. Are you following me?